Hi all, good morning. Today's topic is 8259, that is Programmable Interrupt Controller IC. We will call it as PIC, PIC, 8259 PIC, Programmable Interrupt Controller. Okay. Actually, this Programmable Interrupt Controller IC is an interfacing IC. In 8086, it is used to handle this multiple interrupt request coming from the peripheral device. So for handling these multiple interrupt requests, we are using this programmable interrupt controller 8259. It is a IC which was designed by Intel. Initially, this 8259 was designed for interfacing it with the 8085 microprocessor. Later, the advanced version of this 8259 is introduced. So that was compatible with the 8-bit processor and the 16-bit processor. Okay, so first we can see the features of this 8259 programmable interrupt controller. As we said, uh, this chip was designed, the chip is designed for 8085 microprocessor and 8086 microprocessor. Both the microprocessor we can use this 8259, that is programmable interrupt controller IC. Okay, here normal 8259 programmable interrupt controller that works with the 8-bit processor only. That means it is for 8085 microprocessor. Then the advanced version of this 8259, that is 8259A. Okay, that work both 8-bit processor and 16-bit processor. That means it will work both 8085 microprocessor and 8086 microprocessor. Because as we studied that 8085 microprocessor is an 8-bit microprocessor and 8086, that is 16-bit microprocessor. So 8259A. Okay, so it works with a 8-bit and a 16-bit processor. And also 8259 programmable interrupt controller can manage, it can be programmed either in edge triggered or in level triggered mode. Okay, it can be programmed either in edge triggered or in level triggered mode. And also we can mask the individual bits of interrupt request that is coming from the peripheral by using this 8259 programmable interrupt controller IC. Okay, we can mask individual bits of the interrupt request coming from the peripheral. Okay, and also 8259 IC can manage 8 interrupts. That means it has 8 interrupt lines or 8 interrupt request lines are there for managing 8 interrupts. In normal case, 8259 can manage 8 interrupts according to the instruction written into its control register. And also it can be expanded up to 64 interrupts in cascade mode. Okay, in cascade mode. And also this 8259 programmable interrupt controller IC can prioritize these interrupts. Okay, as we studied that it can manage 8 interrupts at a time, means 8 interrupt request lines are there in 8259. And by using this programmable interrupt controller, each input, these input can be prioritized. Okay, so based on the priority, it will provide the service. Okay, so these are the features of 8259 programmable interrupt controller IC. First one, this chip is designed for 8085 and 8086 processor. In that, 8259 works with 8-bit processor and 8259A. That works with the 8-bit and 16-bit processor, and it can be managed, it can be programmed either in edge triggered or in level triggered mode. And we can mask individual bits of interrupt request register. Okay. And also this 8259 can manage 8 interrupts. Normal case, a single IC, programmable interrupt controller IC, can manage 8 interrupts, and also it can manage up to 64 interrupts. It is in the case of cascaded mode. Okay. And these interrupts can prioritize these interrupts inputs by using this 8259 programmable interrupt controller IC. Okay, so these are the features of this 8259 programmable interrupt controller IC. Next, we can see the architecture diagram. So this is the block diagram of our 8259 programmable interrupt controller IC. Okay, here in this architecture you can see that different blocks are there. Data bus buffer is the read write control logic is the cascade buffer or comparator is the control logic, interrupt request register, priority resolver, in service register, interrupt mask register. Okay, so these are the different blocks present in this 8259 architecture. Okay, control register, interrupt request register, priority resolver, in service register, interrupt mask register, data bus buffer, read write control logic, and a cascade buffer comparator. Okay, all these blocks are connected by using this internal bus. Okay, internal bus. All these units are internally connected by a bus that we will call it as the internal bus of 8259. Okay, all these units are connected. Now we can see the functions of each block in 8259. First block is this one, that is interrupt request register. Okay, it is a register. Here it says the interrupt request register. Okay. Actually, the main function of this interrupt request register is used to store the interrupt request. Okay, the interrupt requests that is generated from the peripheral are to be stored in this interrupt request register. Okay, so there are 8 interrupt lines are there that is connected to this interrupt request register. These are the 8 lines: IR0, IR1, IR2 up to IR7. Okay, 8 interrupt request lines are there. It is connected to this interrupt request register. Okay, so the interrupt request register will store 8 interrupt requests. Okay, so it can store 8 interrupt requests. So that is what the duty of an interrupt request register. Okay, so what is the function of interrupt request register? This unit store the interrupt request generated by the peripheral device. Okay, it is store the interrupt request that is generated by the peripheral device. And we know that it has 8 interrupt lines, IR0 to IR7. So it can store 8 interrupt requests requesting service on the processor. Okay, so it can store 8 interrupt requests, IR0 to IR7. Okay, so that is interrupt request register. Then Next, one more register is here. You can see this one. It is in service register. In service register. That is also a register. We know that register is used to store some values. Okay. Here, in service register, the main duty of this in service register, it will store the interrupt requests which are currently being executed. Okay, the interrupt which is currently being executed, that will be stored into the whose information will be stored in this in service register. Okay, so in service register will store the interrupt requests which are currently being executed. Okay, interrupt request register will store the ah, interrupt requests. 8 interrupts requests at a time it can store. So from that it will select one interrupt to perform its to provide its service. Okay, so in service register will store the interrupt requests which are currently being executed. Okay, so that is in service register. And then next one is interrupt mask registries. Okay, interrupt mask register. It is also register means it will store something. Okay, here in interrupt mask register, it store the interrupt which has to be masked. Okay, that means it store the bits required to mask the interrupt. Okay, so that is a content present in interrupt mask register. Okay, so interrupt mask register will store the interrupt request which has to be masked. As we studied there are two types of interrupts are there. One is non-maskable interrupt and maskable interrupt. Here, in case of maskable interrupt, maskable means we can enable or disable those interrupt by setting the interrupt flag. Okay, and non-maskable means what was non-maskable? Non-maskable means we cannot mask that interrupt. Okay, here in interrupt mask register, in interrupt mask register, it will store the interrupt request which has to be masked, which have to be masked. That means it store the bits required to mask the interrupter. Okay, so that will be stored in this interrupt mask register. Okay, so these are the three so these are the three registers. Interrupt request register, 7 interrupt request can it can hold 7 interrupt requests. So in service register will store the currently being executed interrupt. Then interrupt mask register that will store the maskable interrupt information. Okay, then one more block is here, that is priority resolver. Okay, so what was the duty of priority resolver? We can discuss that. Priority resolver. Here in priority resolver, what it will do is it will check all these three it will check all these three registers. Okay, that means the interrupt request register, in service register, interrupt mask register, and it will set the priority of those interrupts. Priority. Okay, so that is the first duty, priority resolver. Okay, so it will set the priority while examining after examining all the register content. Okay, so priority resolver will set the priority. Okay, then according to that priority the interrupt will get its service. Okay, that means interrupt with higher priority sent to higher priority will set ISR. That means in service register. Okay, interrupter with a higher priority will move to ISR. Okay, and interrupter with a lower priority has to wait. Okay, so priority resolver. The duty of the priority resolver is to set the priority of these interrupts. Okay, that is priority resolver. Okay, in normal situation, IRC, the interrupt request which is coming through the pin IR0, okay, which has the highest priority. Okay, in normal case, and IR7 that has the lowest priority, but you can change by writing programs. Okay, that is also possible. Okay, but in normal situation, the highest priority interval interrupt request is present in IR0 pin. Okay, and the lowest priority interrupt request will be in IR7. Okay, so that is interrupt, sorry, priority resolver. So what is the duty of priority resolver? It examine all these three registers, that is interrupt request register, in service register, and interrupt mask register, then set the priority of these interrupts. Okay, and according to that priority it will what that means interrupt with the higher priority is set in ISR register. Okay, so and also in normal case, this point also you need to remember, in normal case highest priority interrupt request will be available in IR0 pin, and lowest priority will be available in IR7 pin. Okay, so that's all about this complete block. Then next block is control logic. Okay, this one, control logic. We can say what it is a heart of the architecture, because everything is controlled by using this control logic. Okay, all the operations that is associated with the 8259 IC are controlled by this control logic. Okay, that means it control all the operations of the system. Okay, control all the operations of the system. That means what are the duties of here? Here, by examining this block diagram, you can say that it send the INT request, INT signal to the processor. Okay, it will send the interrupt request signal to the processor whenever an interrupt request is generated, and also it receive an INTA signal from the processor to the 8259. Okay, it will receive whenever a processor demand the address of an interrupt service. It receive an INTA signal. What is INTA signal and INTA signal? That you know that. Okay, INTA signal means this is the interrupt request signal, and INTA means it is an acknowledgement signal that is coming from the processor. Okay, it is the acknowledgement signal coming from the processor. Okay, and also this control logic, it is the duty of the control logic to provide the address of the interrupt service routine. Okay, so through this data bus, it will provide the address of that interrupt service routine also. Okay, so that's all about control logic. So what are the points you need to remember in control logic? Nuha Salih. Nuha. Nuha. What do you mean by 8259? What are the features of 8259? Nuha. Nuha. Nuha, unmute your mic. Nuha Salih. Nuha Salih. Mic unmute ചെയ്യൂ എന്നിട്ട് പറയൂ എന്താണ് 8259 ഫീച്ചേഴ്സുകൾ. എന്തിനാ നൂഹ ഇപ്പൊ പ്രസന്റ് എന്ന് എവിടെ ഇട്ടത്? നൂഹ നൂഹ സാലിഹ് പ്രസന്റ് ആണോ നൂഹ സാലിക്ക്? ഓക്കെ, വി ക്യാൻ കണ്ടിന്യൂ. നമ്മൾ എവിടെയായിരുന്നു പറഞ്ഞത്? ഇന്ററപ്റ്റ് കൺട്രോൾ ലോജിക്. ഓക്കെ, interrupt control logic, we can say it is the heart of the architecture. That means it control all the operations of the system, or it will control all the operations of the system. That means it send INTR signal to the processor whenever an interrupt request is generated, and also it will receive INTA signal from the processor when processor demand the address of the interrupt service routine. And the control logic is responsible for providing the address of ISR, interrupt service routine, through the data bus. Okay, the next block is this one, data bus. Okay, data bus, actually it is a tri-state buffer. Okay, it is a tri-state buffer and whose size is 8 bit, D0 to D7. Okay, 8 bit. So it interfaces the internal bus, that means the internal data bus of the processor. Okay, so this will connect the internal data bus of the processor. So the 86 microprocessor can send the control signal or receive the control signal from the 8259 using this data bus. Okay, so using this data bus, the 8086 processor will send and receive the control and the status signals from this 8259 is. Okay, so through this data bus buffer it will communicate. Okay, so that is data bus buffer. It is an 8-bit tri-state buffer. Okay, it is an 8-bit tri-state buffer. And then next one is what? Read-write logic. Okay, read-write logic. Actually, this read-write logic will work when only the CS, that means the chip selection. Okay, chip selection, CS will become low, then only it will, this read-write logic will work. Okay, actually this block is responsible for the flow of data depending on the RD or WR bar and A0 pin. That means if the data is from 8086 processor to 8259 IC, or from 8259 IC to processor. Okay, so that is decided by using this read-write logic. Okay, read-write logic. Then last block is cascade buffer. Okay, cascade buffer or comparator. Actually, this block is used to increase the interrupt capability. Okay, That means we can cascade a number of pin using this cascade buffer. Okay, that means in order to increase the interrupt handling capability. Normally it can handle 8 interrupt. If you want to increase your interrupt capability, interrupt handling capability up to 64, for that you will use this cascade buffer. Okay, cascade buffer. And it work in master mode also and slave mode also. Okay, 3 input pins are there: CAS0, CAS1, CAS2, and enable. Okay, this cascade buffer is used to, main function is it is used to increase the interrupt handling capability. Okay, it is used to increase the interrupt handling capability. Okay, so these are the different blocks present in the architecture of 8259 IC. Okay, interrupt request register, priority resolver, in service register, interrupt mask register. Interrupt request register means store the interrupt request. Okay, in service register will store the currently being serviced interrupts request, and the interrupt mask register will store the maskable interrupt. Priority resolver will set the priority. Control logic will control the entire operation. That means it will send the interrupt request to the processor, or also it will receive the acknowledgement signal from the processor, and also it will send the address of ISR through this data bus. Okay, and the data bus is it is a tri-state buffer, 8-bit storage. Okay, used to connect the internal bus of the processor. Okay, then read write logic is responsible for the flow of data between the processor and the 8259. Okay, well, from processor to 8259 or from 8259 to processor. Then last block is cascade buffer. It is used to increase the interrupt capability, interrupt handling capability. Cascade buffers are used to increase the interrupt handling capability. Okay, so these are the parts. ഇത് തന്നെയാണ് ഞാൻ എക്സ്പ്ലെയിൻ ചെയ്ത കാര്യങ്ങൾ തന്നെയാണ്. Control logic is the read write logic, data bus buffer, and then 3 registers are there: IRR, that means interrupt request register, in service register, and interrupt mask register. Then priority resolver and cascade buffer. Okay, cascade buffer. Then what was interrupt request register? Which store all the interrupt requests, okay, generated by the peripheral device in its order to serve them one by one on the priority base. Okay, interrupt request register will store the interrupt request. Okay, and in service register store all the interrupt requests those are being served. Okay, it is store all the interrupt requests those are being served. ISR keep track of the request being served. Okay, then priority resolver is the what is the duty of priority resolver? Determine the priority of the interrupt request. Okay, it will determine the priority of the interrupt request, and the highest priority is selected and stored in the corresponding bit of ISR during an INTA pulse. Okay, the INTA pulse വന്നു കഴിഞ്ഞാൽ എന്താണ് highest priority ഉള്ളത്, it will given to ISR. Normally the IR0 has the highest priority. That means the request coming from the IR0 pin has the highest priority, while compare with the that means IR7, which has the lowest priority, normally in fixed priority mode. Okay, and also the priorities may be altered by programming in the 8259. Okay, we can set a rotating priority mode also. Okay, so priority resolver is used to set the priority. Okay, according to that priority, the interrupt request will get the service. Okay, normally highest priority is IR0 and the lowest priority is IR7. And interrupt mask register is it store the interrupt level. Sorry, in different interrupt request level, which has to be masked. Okay, so what are all the interrupts that can be masked? It will be stored in the interrupt mask register. Okay, store bits required to mask the interrupt inputs. Okay, and control logic is the, what is the duty of control logic? It controls the all over operations of the system. Okay, so that is control logic. Manage the interrupt and the interrupt acknowledgement signal to be sent to the CPU for serving one of the 8 interrupt requests, and also it accepts the interrupt acknowledge INTA signal from CPU. Okay, and also it will release the interrupt vector address to the data bus, as we said that ISR address. Okay, so that is control logic, interrupt control logic. Then data bus buffer is there. It is a tri-state buffer, bi-directional buffer. Okay, uh, store the sorry, it is used to interface the internal system bus of the microprocessor and the 8259 IC. Okay, then read write control logic is the, okay, this block works only when the value of CS is low. Chip select logic low ആകുമ്പോഴാണ് that will be worked. Okay, and this block is responsible for the flow of data depending upon the inputs of RD and WR. Okay, if these two pins are active, they are used for read and write operation. Then last one is cascade buffer comparator. What is the duty of cascade buffer comparator? It is used to increase the interrupt handling capability. Okay, normally it's 8 interrupt, but by using this cascade buffer pins, you can extend it up to 64. Okay, so in that case, it will store all the, it compare the all the IDs of all 8259 A's used in that system. Okay, so it will work in two mode. One is master mode and the next mode is slave mode. Okay, in master mode, these IO pins, that is CAS 0 to 2, CAS 0, CAS 1, CAS 2. These pins are act as an output, and in slave mode, all these pins are act as an input pins. Okay, so this is the architecture of our 8259 IC. Okay, so this is the architecture of 8259 IC. ഇതാണ് നമ്മുടെ ആർക്കിടെക്ചർ. എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടോ ഇതിൽ? ഇല്ല എങ്കിൽ നമുക്ക് അറ്റൻഡൻസ് എടുക്കാം. ആശിഷ്, അഭിനവ്, അഭിഷേക്, ആദിത്യ, ഐശ്വര്യ, അഖിൽ സി വി, അഖിൽ കെ, അമൽ, ആമിന, അനയ, നിങ്ങളെ വിളിക്കുന്ന ക്രമത്തിൽ ഇട്ടാൽ മതി, അല്ലാതെ ഇട്ട് കഴിഞ്ഞാൽ എനിക്ക് തിരിയില്ലേ. ഞാൻ നിങ്ങളുടെ അറ്റൻഡൻസ് വിളിക്കുന്ന ക്രമത്തിൽ മാത്രം ഇട്ടാൽ മതി നിങ്ങൾ. അനിരുദ്ധ്, അൻഷിത, അനൂജ, അനുപമ, ആരോമൽ, അർപ്പിത്, അരുൺദത്ത്, അശ്വിൻ, ഫസ്ന, ഫാത്തിമത്തുൽ റംഷാദ, ഹൃദുൽ, ജെറീഷ്, ഖദീജ, ലിഖിത്, മറിയം ലിയാന, മിഥുൻ, മുഹമ്മദ് നാസിഫ്, റാസി, മിനാജ്, നിഹാൽ, സാലിഹ്, ഷഫി, നബീൽ, നന്ദ, നന്ദിത, നിവേദ്യ, പ്രിൻസ്, നൂഹ, ഋഷികേശ്, റിസ്വിൻ, ഋത്തിക്, രോഹിത്, സഫീൽ, സങ്കീർത്തന, സാരൻ, സേജൽ, ഷബിൻ, സെവിൻ, ശിഷാജ്, തനുശ്രീ, തേജ, തുളസി, വൈഷ്ണവി, വിഷ്ണു, വൈഷ്ണ, യാദവ്, അമൽ. ഓക്കെ, അടുത്ത ക്ലാസ്.
സാറേ ലിഖിത് പ്രസന്റ് നെറ്റ് കേട്ടായിരുന്നു.
ലിഖിത് ആണോ? റോൾ നമ്പർ എത്രയാണ് ലിഖിത്തിന്റെ?
26.
26. ലിഖിത് എൻവിയ.
അതെ സാർ.
ഓക്കെ, ശരി.